Okay, so for my claims is that the null hypothesis agrees that the average amount of money poly students spends on food daily is $10, while the alternative one actually disagrees with it and does not agree that it's $10. So I found this from smartweb.sg, and that the estimated cost for food alone in school for poly students is actually $46. So finding the median for that is $5 times 2 meals, so $10 per day. Okay, so for the collection of my data, I actually did a Google form on this, and the topic on it was how much money do you spend on average in school for food per day. So I found 35 people to do this, and my sample deviation afterwards was 3.77, and my sample average was $8.20. Alright, so for this page, right, it's actually just proof for you to see that I actually use the Excel to find the sample size, sample standard deviation, and sample mean. Alright, so carrying out the hypothesis test. Over at the top here, we see a sample size, sample mean, and sample deviation, as well as the population mean, which is $10. And we will carry out the hypothesis test using the significant level of 5%, or otherwise known as 0.05. So why do we find the t-value here is because we actually do not know the population standard deviation, as it was not listed in the form or anything. So we use t equals to mean minus population mean over sample deviation divided by square root of the number, which is 35. You will get t equals to 820 minus 10 over 3.773 divided by square root of 35. This will actually give us t value of equals to minus 2.82241, and then rounding off to minus 2.88822. Alright, now we will find the degrees of freedom. So degrees of freedom, or how to find it, is basically just the number minus 1. So 35 minus 1 equals to 34. And then we have to find the t value when it's actually 34 on the math booklet, the critical value. So I'm not going to say the calculations, however, I found in the math booklet, you can see on the right side over here, then the t value is actually equal to 2.032. And since negative 2.032 is actually greater compared to the t value earlier, so the crib value is greater than the t value, we can actually base our sample results that there is sufficient evidence at the 5% significance level to reject the claim that students spend an average of $10 a day in poly. And actually, the data suggests that they actually spend lesser than $10 per day. So now we'll be constructing and interpreting the 95% confidence interval. We'll be using the confidence interval, or otherwise known as CI formula, and CI equals to mean plus minus crit t value times the standard error. The standard error, which is just standard deviation, sample standard deviation over the square root of n. So over there I did the calculations already on the right, you can see for yourself. And basically what we get from these calculations is that we get $6.90 and $9.50. So what we can actually infer from this is that the confidence interval means we are 95% confident that the true average amount of money poly students spends per day is $6.90 and $9.50. Since the claim says that students spend $10 per day, and since $10 is not actually inside the interval suggests that the claim is likely too high. Hence, based on this data, students spend less than $10 averagely per day.